In the previous lessons, we looked at reflections from a graphical point of view. Reflection in the x-axis and reflection in the y-axis by looking at the coordinates of the points and changing them graphically. But now we can actually express these reflections symbolically and see how the symbols and the graphs are connected. For the reflection in the y-axis, recall that if we were reflecting in the y-axis, we change the x-coordinates and we keep the y-coordinates the same. So we had the point AB plotted, its reflection is going to be negative AB in the y-axis. We can also look at this in response to the symbolic form of the function. Now, when we're doing this, we're creating a new function. So our original function may have been f of x. Now we're going to create a new function called g of x from this reflection. You'll see that in our notes as we go along. So to obtain the symbolic form of the reflection in the y-axis for the function y equals f of x, we're going to replace the x with negative x. We're changing the x-coordinate sign, so we're making it opposite. Reflection in the y-axis of the function f of x is f of negative x. And we're going to rewrite this, the function g, give it a new name. So let's walk through a quick example. F of x is x plus 1. I'm going to do the same thing over to the side. F of x is x plus 1. To get the reflection of f, we're going to put in negative x, so that everywhere I see an x in my original f function, I'm going to write negative x. So then my new function g, which is the reflection of f, becomes negative x plus 1, as we see here. To check that the new function is in fact a reflection of f of x, let's look at the tables of values. Negative 1, 0 is a point on f. If we change the x-coordinate to be positive 1, 1, 0 is a point on g. 0, 1 on f stays the same. 0 for an x, nothing happens. 0 for x means it's already on the y-axis, so we don't move it. Up the point 1, 2 on f, change the x to be negative, becomes negative 1, 2 on g. We can see this graphed out. Here are 3 original ordered pairs for f of x. Notice that for g of x, changing the x-coordinates because we're reflecting across the y-axis. And so here, this function, g of x, is negative x plus 1. Now we're going to be given a function and its graph. We want to find the symbolic expression, make a table of values, and then sketch the graph of the reflection. Remember to change your function's name. Let's work through this one together. F of x is 2x minus 1. So to get the reflection, I replace the x with a negative x. 2x minus 1, I'll make my skeleton. Negative x goes in the parentheses, and I can simplify it. Negative 2x minus 1, and I'm going to call this new function g. You could call it something different. We can create a table. We'll just pick negative 1, 0, and 1. Plugging in negative 1 into f. 2 times negative 1 minus 1, that's going to give me a negative 3. Plugging in 0 is a negative 1, and plugging in 1 is a positive 1. For g, plugging in a negative 1 will give me 1. Plugging in a 0 will give me negative 1. Plugging in positive 1 gives me negative 3. And so I can see that if x is negative 1, f of x is negative 3, but the g of x being negative 3 happens when x is positive 1. My x-coordinates are changing signs. And then we can graph. And I have my reflection across the y-axis. Repeat the same process for problems 6 and 7. Try them on your own. Pause. Resume when you're ready to check. Alright, let's check your work. If you ended your g of x function as negative x minus 1 squared, that's okay. I did a little bit of algebra here and got a simpler form for g of x. So either of these will graph the exact same image for g of x here. Looking at number 7, similarly, if you got negative x to the third with the negative inside the parentheses, that's okay. I did a little bit more algebra and I got negative x to the third because negative 1 to the third still is negative 1. Both of these are equivalent, so they're going to give me the same graph. Again, noticing that reflection across the y-axis. Here we have f of x equals 1 over x. If I'm reflecting across the y-axis, replace the x with a negative x, I get 1 over negative x, or I could write that as negative 1 over x. This flips my graph across the y-axis. And then one last one, f of x equals x squared plus 1. Tried this one on your own. Pause, resume, and we'll talk about it. This one's pretty interesting. If you try to plug in a negative x squared, negative x times negative x, will give me positive x squared. But that's exactly the same as my original function. So a graph is its own reflection. When this happens, this type of graph is said to be symmetric with respect to the y-axis. The graph itself, if I fold my paper at the y-axis, the two halves of the graph will be on top of each other. And that's what we mean by symmetric. So reflecting gives us a new graph. Symmetric is one function itself. These also have another name. They're called even functions if they are symmetric with respect to the y-axis.